Okay, this is part two, take two. I'm going to do this in one part, and we'll do the whole thing. Everybody's kind of like looking at me like, didn't we just do this? Yeah, so we know what we're really doing now, don't we? Okay, we all know what we're doing. All right, so you have FF and FP as the contrary forces. Yes, you have the weight here as the force that's pulling it down. So it's going to go like this, right? The system has a mass of, remember, has a mass of 24 kilograms. So it's going to be the net force equals the weight 2 minus FP1 plus FF1, correct? So that's going to be F net equals what? 160?
97.
Correct? Because that's actually going to be accelerating it. Minus
48.
was 48 and 14.7. We'll just write it in. 48 plus 14.7. So the force, the net force equals 97.3 newtons. Okay, that's the net force. That's what's driving it. We know that, correct? It's the contrary forces going one way, 160 coming down. So it's going to be 160 plus these, or minus these, correct? You could actually say plus this, correct? Because we know that these are both negative. Right? You know that they're both negative. So you could actually make everything a plus. Okay? Because those are negative, these are positive. Yes? So you're going to add these. If you want to do this right in terms of vectors, correct? It's going to be FW plus the sum of the negative vectors. Okay? That's negative. Negative. Okay, easy? All right. So now the acceleration is going to be F net over M1 plus M2 equals acceleration. That's not working very well, is it? Okay, and what is 97.3 divided by 24? So it's going to be 97.3 divided by 24. This is kilograms. This is newtons. And this is going to be 4.1 meters per second squared. Correct? Easy? Yes or no? Okay. And then what's this going to be down here? This is going to be the what? What else do we have to do? The tension, correct? So the tension is going to be equal to, the tension here is going to be equal to the weight minus the support force. Correct? It'll be equal to the weight minus the support force. So it'll be, what's 10 times 16? 160 newtons? Right? And then what is the
65.
What is the support force?
65.6.
The support force is going to be, isn't it going to be what? The mass of what? It'll be
65.
mass 2 times what? Times A, right? Isn't that what it's going to be? Remember we talked about this? What do you mean by the tension? Well, if I go like this eraser weighs less. How much less does it weigh? Well, the mass of this times its acceleration, and subtract that from the actual weight of the object. So it's going to be, can I write it over here? Can you see over here? So it'll be 160 newtons minus, what is 16 times 16 kilograms times 4.1, going to be 64, 65, 65.6 newtons. So Ft is going to be
4.4.
94.4. That's the tension. So let's just quickly review what we did, okay? We found the acceleration of the system. We have a free body diagram. The contrary forces are both negative because we're saying that the direction of motion is going to be positive, that this system will go like this, correct? The system will go like this, and these are contrary. 160 or 16 newtons, 160 newtons, 16 kilograms will accelerate it, correct? But the system that's accelerating is 24 kilograms, right? The system that's accelerating is 24 kilograms. So you can find the net force, and then the acceleration will be based on the total mass of the system, correct? Now, this system is falling, so the tension in that rope will be dependent upon this accelerating downward, making the tension on the rope less. If you're in an elevator, has anybody ever taken an elevator down? Anybody? Well, if you've taken an elevator up, you've probably taken one down, unless you're trapped on a floor in your mind above where we are now. That's a little weird, isn't it? Could consider. Omar's going, that would be weird, yeah. So, if you take that elevator down, don't you feel lighter? Yes? Well, you feel lighter by how much? Your weight minus your mass times the acceleration downward. That's how less you feel, correct? And that's the same thing, that's what the tension is. So the tension is going to be your weight, or the weight of the object that's accelerating it, minus the support force. Correct? Get it? Now, on Monday, we'll have a quiz on this. Now, I am going to put the Sisyphus problem on the internet. Correct? And you're responsible for it. It's the same idea. Right? You don't know who he was. I may be pronouncing it incorrectly. I'm sure I'm going to get some mail from some Greek people. I call it Sisyphus, but anybody ever heard of Sisyphus? Yeah? Yeah, they've heard of it. Okay. I have a very literary class. So make sure you know how to do that problem. It's a short period today. We're leaving early. Have a be careful out there. Have a great weekend. We're off.